Well, I shall start again. Welcome everyone to an exciting second day of SIMS, and welcome to session 3 of the symposium. Topic of the session is decentralization and distribution. And we have 3 very interesting talks in this session. The first one on decentralized self-adaptive systems, a mapping study, will be presented by Federico Quinn. And Federico is here, and I believe you can share your slides to start the presentation. You have 5 minutes.
Okay, thank you, Ron. Let me quickly share my screen. I hope everything is visible.
It is visible.
Okay, great. Thank you. So, hi, my name is Federico, and I'll quickly be presenting our paper titled Decentralized Self-Adaptive Systems, a Mapping Study. And I've done this work together with Danny and with Omid. So first, I'll quickly introduce the scope we have used to perform this mapping study. We have 3 main criteria. First criteria being that we looked at papers that specifically applied architecture-based adaptation. And then in more detail, we were interested in papers that apply MAPE-based architecture. And then in terms of the second kind of criteria that we have listed, we kind of have a look at the degree of decentralization that is employed in the papers, and we apply a minimum level of decentralization that is required for a paper to be included. So what we mean specifically by this is that one of the MAPE functions, so monitoring, analyzing, planning, or executing, is organized in a decentralized fashion, meaning that they are spread over multiple components and that these components interact with each other. And then as a third criteria, we focus on 20 main venues, including SIEMS, SASO, TAS, and other similar venues that specifically target self-adaptive works or works that also are closely related to self-adaptation. And to collect those papers, we have used an automatic search query over different digital libraries and collected them that way. Then on top of this, we have also applied snowballing to a community study published in 2013, I think as a result of a DAXTools seminar. And we have looked at papers that have cited this specific paper, describing 5 different decentralization patterns. And then if they meet the criteria as listed above as well, then we have included those. Then we have processed those papers, and we have listed 4 research questions to analyze different aspects of decentralization. And I'll quickly go through a few of those results. So in terms of the first research question, we were specifically interested in the motivation of using decentralization in self-adaptation. And then in terms of motivation, the most prevalent ones that we have found is 1, nature of the problem, 2, scalability, and 3, reliability. And maybe a quick elaboration on nature of the problem. We specifically mean that the problem that they are trying to solve dictates the need for a decentralized solution. So an obvious example there is that there is no central authority that is allowed in the system. And in that sense, the nature of the problem dictates the need for decentralization. And then in terms of listed trade-offs, I'll quickly list 2 that are most commonly referred. 1 is design complexity, and 2 is suboptimal solutions as kind of an implication of using decentralization. Also, an important remark is that design complexity was not always listed as a negative, but sometimes listed as a positive, as these smaller systems to be designed was a little bit easier to design since they were smaller, although maybe the decentralization factor might also complicate things a bit more. Then second, we are specifically interested in terms of the architecture that is being used to orchestrate this decentralization. And then at first, we take a look at individual MAPE functions and see how frequently these are organized in the decentralized fashion. In terms of results, we see that monitoring is the most often decentralized, but the other MAPE functions are still quite often decentralized, so it's spread out quite well. Then in the second case, we want to look at the aggregated adaptation functions in the sense that, for example, we look at a case-by-case basis, and in each case, we try to look at the combination of adaptation functions that are jointly decentralized in these specific cases. And if we look at results there, we can see that monitor executor is very often decentralized, and then other than that, we think it's also worth mentioning that the complete MAPE loop is also often decentralized. And then as a third point for architecture, we also take a look at the 5 decentralization patterns that were identified from the community paper before. And then here we can see that hierarchical control and information sharing are often decentralized. And then other than that, also worth mentioning is compound patterns, where we have not just 1 decentralization pattern that has been applied in these case studies, but a combination of 2 of these patterns that has been applied, but still covering, of course, 1 of those or 2 of those 5 original decentralization patterns. Then for the third research question, we are specifically interested in terms of communication and what kind of coordination mechanism that is being used. So a quick highlight of the results there is in terms of communication, we see that intermediary communication and direct messages is most prevalent. With intermediary, we mean, for example, some sort of middleware, and then direct messages kind of speaks for itself. In terms of coordination, we see that for coordination, that client-server is very prevalent. Publish subscribe is also very prevalent, process-based, where we have, for example, well-defined interfaces between producers and consumers, kind of in the sense that a complete protocol is being described, but there's quite a few of them here. So the results is also very nice here. Then in terms of limitations and challenges, I'll quickly highlight a few that are listed quite often. For limitations, we have, for example, modeling restrictions. You can think of, for example, modeling certain uncertainties. Underlying assumption about, for example, communication channels. And then in terms of open challenges, we have enhancing coordination mechanism, improving decision-making process, improving on overall system goals in terms of suboptimality like before, and so on and so forth. And then where do we want to go from this? We want to provide some enhanced patterns in the future. So what we have here is one of the original patterns from the community paper, information sharing, where we have the monitoring component that is decentralized over multiple components. And what we want to do is we want to add a coordination model and a coordination channel to this pattern, which explicitly model the coordination mechanism and the communication that is used to realize this coordination. So an example of this is, for example, tuple-based coordination, where tuples are being put in a sort of tuple space.
If you can conclude, Federico.
Yes. Sorry. Which is managed by an intermediary, which is basically some, for example, a middleware. And then these tuples represent the information that is being shared between the monitoring components. So thank you for listening. Sorry for going a bit over time.
Thank you for the interesting talk. There will be questions at the end. Mm-hmm. So we are moving on to the second paper presented in this session. Messias Filio will tell us about his and his colleagues' work on self-adaptive microservice-based systems.
So can you see my screen?
We can.
So hello everyone, I am Messias Filio from the State University of Ceará, and I'm here to present briefly the paper entitled Self-Adaptive Microservice-Based Systems and Landscape and Research Opportunities that was done together with other colleagues also from the State University of Ceará. And in this work, we did a systematic mapping and exploring the current scenario of microservices and self-adaptation. So the context in which we are inserted is that the microservice architecture is growing more and more, and because of its benefits and being adopted by several companies and also being explored in the academic environment. And however, managing systems that rely on a microservice architecture has become a challenge. And because as these services increase, so the complexity also increases. And in this context, self-adaptation has been used to maintain this complexity at manageable levels. So from this scenario, we verified how self-adaptation has been used or applied in the context of microservices. And for that, we have done a systematic mapping in which we analyzed 21 studies from 5 electronic databases and answered 10 research questions that guided the work. And this research was conducted between February and May 20. So talking quickly, we can highlight some results that were found. So first, in this graphic, we can see that the first work was published in 2015. And after that, the number of works published grown. And between the years of 2017 and 2019, we had the largest number of published works. And so basically, the approaches used MapK as the main control loop for the solutions and proposals. And another highlights that most of the proposals are self-adaptive reference architecture models and frameworks that use self-adaptation to ensure more resilient and scalable microservices autonomously. And other property is that self-healing is the most addressed property. And so this property is used, for example, for anomaly detection, and resilient scalability, and reallocation of microservices when they fall, for example, and so on. And the results show that the vast majority of studies used reactive adaptation with 17 studies. And another highlights that the vast majority of studies proposed adaptations in terms of infrastructure, which is related to microservice instances in execution in these regards containers. And finally, we can see that the attributes of performance, scalability, and resilience are the main concern of most of the studies. So based on these results, we pointed some line of research that would be interesting. So the first one is related to the resilience and reliability in microservice composition, and in which we cite that the composition of microservices can be better explored in the application layer. So for example, taking into account the criticality level of failure of microservices during the execution of a choreography or orchestration process. Next, languages and models for adaptation planning. So the use of DSLs or adaptation plans based in abstract models is almost unexplored in the context of microservices. So it would be interesting to explore this area. And the next topic concerns the deployment of microservices that could be an interesting possibility to explore. For example, the automation of deployments as an activity that involves the use of self-adaptation techniques through feedback control loops. And finally, sorry, the use of machine learning and in self-adaptive microservice-based systems that is still in early stages. So there is a great opportunity to add intelligence to different levels of microservice applications. And for example, machine learning can be used to implement more proactive adaptation strategies. So I think that's it. Thank you for your attention.
Thank you very much, Messias. You fitted this very well within 5 minutes. And this brings us to the last short talk in the session, which is on an exemplar for engineering self-adaptive cyber-physical systems of systems. And this talk will be given by Youngjun Shin. Youngjun, please.
Yeah, can you hear me? Okay, let me start. Nice to meet you. I'm Youngjun Shin, an author of an artifact paper. Its title is Platooning Legos, in short. First, let me explain what the platooning is. Platooning is a collaborative driving technique. In a platooning, there are multiple autonomous vehicles or semi-autonomous vehicles. They are cyber-physical systems. They monitor the environment and automatically drives, preventing collision and maximizing its driver speed. In addition, the multiple vehicles communicate with each other and behave as a system of systems. So not only their individual goals, but they achieve collaborative high-level goals. They drive in a row and minimize road occupancy together to minimize their fuel consumptions. As a self-adaptive system engineers, we are, when we design an adaptation mechanisms of a CPSOS or such as platooning, at some point we need to validate our adaptation mechanism with real or simulation-based experiment. However, they have their own limitations. First, the real field experiment is realistic, but it is very expensive, and sometimes there can be safety risks. On the other hand, simulation-based experiment is cheap, but it is hard to express the real environmental uncertainties. So our solution to tackle these limitations is to provide a semi-realistic experimental environment using programmable Legos. The name of experimental environment is Platooning Legos. Its adaptation problem is on an industrial vehicular technique. It is a physical experimental environment, but it is really easy to build and ship using Legos. Although Sims community has accumulated numerous adaptation exemplars until now, but we lack physical ones. So we hope platooning Legos can help engineers who need cheap and realistic experimental environment. This is how we mimic a real platooning vehicle as a Lego robot. It monitors its environment and peer situation using Bluetooth, buttons, ultrasonic sensors, and color sensors. Based on the monitored information, it decides its driving speed and turning ratio. Its adaptation logic can easily implemented as a Python program in the Lego brick. And all building manuals is given in our papers and our repositories. In addition, not only the vehicles, but to mimic the real the driving environment, this is how we mimic the infinite two-lane highways using multiple A4 papers. There are 2 lanes, inner lanes and outer lanes, and you can easily build these our driving environment using multiple A4 papers. Then not only the building manuals, but we also provided you a sample experiment video and its result data. And this is the experiment video that we recorded, and you can watch this on Cloudera or in YouTube. I'm not gonna show this video now, but you can please find this later. And in short, we provided a very cheap physical experimental environment to Sims community. It will help engineers to validate their platooning adaptation techniques easily, as we hope. In shortly, this is the OR. So if you are interested in our experiment or if you have any difficulties to build our platooning Legos in your place, please let us know. So thank you for listening.
Thank you very much as well, Youngjun, for this interesting presentation. This is a very exciting exemplar, which I hope many people will build, possibly of a younger age than those present at this session even. Right, so we started to receive questions for the speakers and co-authors in this session. And the first one is from Andreas. Would you like to ask your question yourself, Andreas?
Yes, absolutely. Thanks, Radu. Hi, everybody. And thanks, Federico, again, for the very nice presentation and the informative work. I really read your paper with pleasure. You probably saw my question in the chat. So, I mean, I fully understand that you look at how you decentralize the MAPE functions. But of course, at some point, you may also have to understand how you decentralize or distribute the MAPE knowledge. Do you already have any insights from your literature analysis on how this may be done, or whether it's considered at all or plainly ignored? This would be really nice to understand. Thanks.
It's hard to say. I think Danny also touched upon it a bit as well. In terms of the coordination mechanism being used, it kind of sometimes incorporates this information. So for example, if we think about market mechanism, then we have, for example, some broker or multiple brokers in the system that kind of maintain this information and share it between different kind of selling agents or similar things like that. But we didn't collect this information explicitly right now. And I think there's also, it's not necessarily the case for all papers, but there are definitely some papers which do not elaborate that much on that aspect, or it's not explicitly modeled. I think also, if I would have to think back about most papers that I've read, I think the information is just directly shared between the different components or different MAPE loops. In terms of localizing it somewhere else, it happens sometimes that there is some repository where they store information and they retrieve information back. But in terms of a general idea, I don't think I can give one at this moment.
All right, okay. And maybe a quick follow-up. So the modeling approach you showed to depict the different forms of decentralization, would this facilitate modeling the knowledge element too? Or is this not foreseen in this approach?
Currently, I think it kind of relates back to the same question, yeah.
Okay.
But yeah, we haven't, I still haven't developed or started developing this thing yet, but I think it's definitely something nice to take into account as well and thinking about that further.
Okay.
But thank you for your question.
Yeah, absolutely. Thank you very much.
Andrea, so if I can, Radu,
Of course.
follow up here. Thank you very much for this. Apparently, this is something that we left implicit because immediately it popped up as questions from different people. Actually, I can say the reason probably why we didn't immediately thought about it, but it is interesting. Eh? But why we didn't thought about it immediately is because when we think about decentralization, we think about some kind of decision making, some kind of functionality that for which components might need to coordinate with one another to come to some conclusion, which can be anything within MAPE. And so, and knowledge in itself is just a means as an interaction facility. You can exchange data, you can of course put data somewhere, and implicitly I think we collect that data through the coordination mechanisms. But I definitely agree with you that it would be better to make it first class also in the diagrams, in the patterns. It was already lacking in the patterns of the community paper. Lacking, I mean, at that time we did it on purpose, not go into that and put it as a future work. But here again, it's something that that might really be considered, like make it a first class would enhance the patterns in terms of understandability. Thank you very much for the comment.
Yeah, absolutely. Yeah.
Next question is from Anna. If you would like to ask your question, Anna.
Can you hear
We can hear you, but not very well.
Hello, now? Can you hear me now?
Much better.
Okay, I'm sorry, I had some mic issues. The question was the same as it was previously asked. So did you consider the knowledge component? Because yes, you're primarily focusing on the first 4 phases of MAPE, but from the experience from reading the papers and looking at this, I was just curious how the knowledge is treated. I'm asking this from experience because I was working on something that I will present on Thursday, where I was using the master-slave pattern, where, for example, in the papers on the pattern, the knowledge is not considered. So I kind of needed to modify that pattern by introducing it was a minor modification, but it's something that I needed to do. And I was just curious what complexity will be brought maybe to this work, or how this work can be extended if you, for example, also consider how the knowledge component is treated across different works, and if you can comment more on this. But I think already was kind of this question was touched.
Well, thank you for the additional comment, and Anna, and I'll move on to Danny's question to Messias.
Messias, I was, in fact, yeah, it's a bit aligned with the previous. I wanted to connect these 2 papers because in the first paper, it was all about decentralization. And then I saw in your talk that you really only looked at the MAPE functions and you didn't say anything about decentralization. So I was wondering whether you have encountered any decentralization when you collected the data for your work, or are all people at the moment in your space just applying centralized adaptation?
Okay, so we had papers that used decentralized adaptation, and I think most of the articles used this type of adaptation, where we have MAPE agents, for example, distributed in containers and checking when necessary to make some adaptation. So they are distributed in containers and acting like agents.
Okay, but then I wonder a bit when I saw your results, but I might have misunderstood it. But in your results, as far as I can recall, you showed then how many occurrences there were of MAPE, for instance, for all the different functions of MAPE. But then I wonder how you count this. What does it mean if, for instance, a system, I'm just curious to understand, if you say I have I count 1 extra for A, what does it mean? Is it, if there are 10 agents, do you count it once? You see what I mean? It was like you looked at MAPE only, which you can do, by the way, but I just wonder how you decided about the numbers of each of these functions, if there would be decentralization.
Yeah. So in fact, we have some articles that say that they are using a decentralized adaptation, but in microservices we didn't have patterns defined. So this question is a little bit difficult to answer.
Okay,
because
Okay, it's not a big deal. I will read the paper and then maybe I will get in
Okay.
touch with you. Thank you very much.
Moving on, Ilias, you have a question for Federico?
Yes, I was wondering, also thinking about the study that we did with Daniel, we presented on Friday about the evaluation of adaptive systems. So there are claims, right, about the decentralized approaches that they bring some benefits, and you have data on this. And for example, scalability is one. But did you look at whether actually there is evidence that or somehow evaluations, comparisons that actually these benefits are reaped, or are they claimed and just remain claimed? Thanks.
Yeah, we were thinking about also including evaluations, but we didn't do it for this study specifically. Although I can remark, if I looked at most of the studies that did make some claims about scalability, then at the end they had some data to back it up as well. Although in terms of comparing it to different results, it's a bit harder. In most cases, it's just a singular evaluation where they try to scale up the system and see what is the result of that. But in general, most of them did provide some data on that.
Right, but it would be interesting also to compare to a non-decentralized, right?
Yes, exactly.
Mm-hmm. Thanks.
Thank you, Ilias and Federico. So moving on, we have a series of questions for Youngjun, whose presentation of the artifact was much enjoyed by all the audience. Would you like to start, Danny?
Yes, Youngjun, I think this was really a nice artifact. I like it a lot. You did a very clever job by making the physical artifact and let people build it themselves by providing all the facilities they need. Actually, we did this Delta IoT artifact a few years ago. It is a physical artifact, but I can tell you from experience, only a few people were able to use the physical artifact because you have to do a lot of maintenance. These IoT devices were deployed all over the buildings, and at some point there was no interest anymore from the people we worked on it, and so we had to remove it. And then, of course, your artifact disappears. Luckily, we have a good simulator, but you did a clever way to say, okay, we provide you all the things you need to build it yourself. You can just print the layout of the floor. Really great idea. I was just wondering whether you could elaborate a little bit. Let's say motivate me and the other people here in the audience for what kind of problems I could use your artifact. What type of adaptation problems could I work on or solutions built for which your artifact could be an exemplar to use?
Okay, thank you, Danny. Actually, I also tried to use your Delta IoT, and unfortunately, I failed. So. Thank you for your comments. So yeah, as you mentioned, this is physical exemplar, but this will be also private for every users of our exemplar. But in our paper, we also elaborated the four goals of the platooning. So there are 2 hard goals and 2 soft goals, and actually among the 4 goals, there are 2 quality aspects of the performances of the platooning. The one is the road occupancy minimization. The road occupancy here is the distance between the first faker to the tail bakers. And another quality aspect of the platooning is the maximizing the travel speed, so we can collect the data, so how they achieve, how they collaborate, and how they decide their adaptation decision to maximize their the driving speed. So those 2 aspects, those 2 quality aspects of the platooning performance can be used to compare other adaptation mechanisms on our exemplar. And actually, there was another question, how much effort to build our exemplar. I think if you are very new to using the Lego programmable Legos, in that case, maybe you will about 5 to 6 hours to build our exemplar from the scratch.
And if I may, that was me asking the question, what do I have to do?
Sorry?
What do I need to do? I want to motivate
Ah.
also myself and others the other way. See, that is a follow-up really
Yeah,
from
yeah.
Danny.
Yeah. First, you will you need to have the EV3 Lego bricks, and then we provided you whole building manuals, so you can just put the Lego bricks following our manuals. That the manual is in our repository, so it will be very easy to follow. And to build the driving environment, you can just print our building manuals and just cut it and paste on the floor, and then you will have your private physical example.
And if I want to change its adaptation strategy that comes within, what do I have to do?
Yeah, you need to write a Python program on the brick, but you can just simply use the Lego library. The Lego library is really easy. Like just for example, the parameters of driving is just there are two parameters: driving speed in float numbers and turning ratio in float number. Like that, the library is really simple, and you can just write a Python program, and then you will embed that program in each papers, and you can just click the button.
And the sensor measurement, this is handled already via the brick, right? So I get in my Python code the sensor measurements of the different sensors.
Yeah.
Okay.
Yeah, using the Lego library. Yeah, there's an official Python library. Yeah.
Thanks.
Very interesting discussion. You really need to assemble this kit and commercialize it, Youngjun. This community wants to buy several copies for several kits for their students. So an opportunity here. So we'll move on to a question that Janina wants to ask to Federico.
Oh, right. Oh, okay. Thank you. Okay, let me go back there again. I posted a couple of questions. Where am I? Okay. Yeah, so very nice presentation, Federico, and nice study you guys did. I was curious in particular regarding cyber-physical systems, as you mentioned, self-adaptive systems, but nowadays have a broad range of self-adaptive systems. I mean, I see it this way. I'm not sure if my vision is correct, but in that realm, I was wondering cyber-physical systems and more in particular robotics. So you mentioned that scalability was one of the motivations of the primary studies. So I was wondering how many of those studies were related to cyber-physical systems and in particular to robotic, as I mean, from the experience we are building in our research group, scalability is quite an issue, but then you say like the motivation was scalability, and I was wondering how much of scalability has been solved in those studies. Thank you.
That's harder to say. I don't have the data specifically in front of me. I don't think we have collected that specific data either. I can definitely come back to that with data for that, but if I would have to ballpark a figure, I would say, this is a very rough estimate, it's maybe 10 to 20% of the studies that we have related to that, if I would have to put a figure on it.
Right. Okay. Yeah, I have, what is it? Go back there again. Yes, it was what is number 2, or figure number 2, the motivation here. But okay, yeah, so I was just wondering if you guys have noticed or have any impression on that, and how many of those studies are related to cyber-physical systems, or in particular to robotics. As I was curious to know, as it reports here, is about 20 studies out of the 40 studies. So I guess
about
it's
100 in total.
And out of the yeah, okay, so yeah, we'll have to sum up here, so probably like that much. Yeah, so that's just a curiosity I wanted to know, because as you say, like it's a motivation, so I was wondering if there is any solution there that could be also applied to those kind of systems that we're missing somehow.
I will definitely look into it and then come back to you.
Okay, thank you.
Right, so Anna, you had a number of questions and comments on the exemplar?
Yeah, it's one question. So first of all, thank you again. Very interesting work. I enjoyed your presentation and scrolling through the paper. I was interested in maybe hearing more if you can explain how your Lego system addresses the limitations of a simulated system, for example, because the two reasons that you gave on your slides, for example, the low reality and the limited expression of the environmental uncertainties in some ways still hold in your system. So there are no human interactions, there is no complex uncertainty that, for example, I would say cannot be depicted in a simulated system. So maybe ask differently, what is the other gain apart from your system being physical versus using a simulator, if you can elaborate on this.
Yeah, okay, thank you for the question. Yeah, actually, as you mentioned, there's numerous platooning simulators. And so if you want to build your platooning mechanisms, then in that case, you can simply just use that platooning simulators. Maybe that will be more easier than having the physical one. However, although the simulators reality is getting increased, but yeah, actually that is a good news to us. But however, until at some levels, there is some differences in the realistic simulation and reality. So, for example, what we gained in our sample experiment was actually there are independent fakers in the independent physical fakers, and we can collect their own environmental data from that each independent fakers. But sometimes we had an experience on the time, the communication time is not synchronous, for example. But actually those difficulties is not in the simulation. So that is just an example of that what we experienced. And another, in addition, when you use simulation platooning as platooning simulator, that the data that you will get is the simulated ones. But if you use the physical one, then your data has a lot of noises, and sometimes your data are not collected because of some unknown reasons. So those unknown situations, like unknown unknowns, that what they say in our community, are popped up in the physical experiment. So I think that is more realistic than the realistic simulator. So I think that's all I can answer on your questions.
Great, thank you very much.
Yeah.
Right, so brace yourself, Federico, for questions for you now. Bradley, you wanted to ask the first of these questions to Federico.
Yeah, hi, Federico. Actually, my question was very similar to Janaina's question about robots and sense plan act and whether those were included in the survey, especially papers from robotics conferences and things like that, where you might consider path planning and adaptation scenario.
It really depends. I don't think we had many, but we had a few, but most of those, they didn't have a specific map-based architecture, or at least something that closely resembles that. So for that reason, we might not have included that, because otherwise we couldn't have specific results related to those map-based functions. We had a few, but I know quite like a few details of them, but I don't know them in very specific detail.
May I add here, Bradley, one of the things we often discussed papers of this, because then Federico and Omid were collecting data, and then we start discussing, because we really strictly looked at architecture-based adaptation, meaning there is some software that is monitored and adapted. So if you have a sense, what is it? Sense act, decide
Sense plan act.
Yeah, sense by act. And it is just in the environment. I monitor the environment, then I make a decision and I act. This was out of scope. We looked at if on top of that you had a feedback loop, then it was included. Yes. But if it was only a feedback loop in the environment, it was excluded.
I mean, robots have, I mean, what they're sensing is themselves as well, right? And whether they're achieving their goal to the path.
Yeah, then it was included. In these papers were included. If there was like a kind of reflective layer, if you want, they were included. But I have also to say, we looked at a set of conferences, and we looked mainly at conferences from the self-adaptation's point of view, and not so much into robotics and so on. As Federico was saying in the beginning, it was the focus of our study.
I mean, I understand the scope, but I think it would be interesting to kind of look at those communities and be a little more creative about, you know, the way that they organize their adaptations in those communities. To come up with different, maybe there's even more different patterns than just restricting ourselves to the classical patterns that we have in sort of this community and related.
It comes back a bit also to the multi-agent systems domain, because we also encountered that quite a lot. We also included it in our search query. No, we didn't, but we looked at papers. I don't know the specific term anymore. I can't recall it at this point, but we had a lot of papers from multi-agent systems, and we decided not to include them because it's a vastly different domain and it's a very large domain. But it would be interesting to also take a look there and compare these with self-adaptation. I agree.
Thank you.
It's a totally different type of question from Gabriel.
Yes, thanks, Federico, for the nice work. My question is about the enhancements you did to patterns. Like, for example, proposing the market mechanism for decentralized planning. It seems that goes beyond the pattern, because there are many planning approaches that can be used for decentralized planning. So I was wondering, what was the rationale to these enhancements and go beyond the generality of the patterns? So probably you saw some value on doing that.
The idea is that we make it explicit of what kind of coordination mechanism and what kind of communication we would use to organize this decentralization. So the market mechanism, for example, is just one specific instantiation that we could use to realize this decentralized planning or deciding which adaptation plan to go forward with. So it's not necessarily just that one protocol and then one pattern that emerges from that, but for example, one specific instantiation of how to realize some, for example, regional planning from the community paper. So it's not very specific to that one approach. It's just a way to realize it, I think, is, if I understand your question correctly.
Yeah, I mean, yeah, exactly. So that's one way to realize the general pattern. Was, for example, the market mechanism something that you saw in one of the papers?
Yeah, we saw it in quite a few papers. Well, quite a few, at least a few papers, yes.
Okay.
Actually, the patterns that are in the paper are based on the frequencies that we saw them using in the papers. So we only selected those that were most frequently used. And those, in fact, the pattern is something you don't invent. The pattern is something that you see a recurring solution for a problem. And we saw that, I don't know, maybe for this, there were like 5 or 6 instances of it. And then we said, okay, we can classify this as a pattern. If there was only 1 or 2 cases, we said, this is not a pattern yet. It's just maybe an ad hoc solution. And so, but it was very specific, of course, you're right. The pattern could, of course, be much more general, but this is concrete instance that we observed happening in the papers.
I see. Okay, thanks.
Rogerio, you have a couple of questions for Federico as well.
I just want to follow on that question from Gabriel, actually, because I had a similar question to that one. And it's the fact that he's on the same point. So since you've got a very nice pattern, the MAPE part for the decentralized set of patterns, all right? But what looks like by doing that extension, you're breaking up that pattern, all right? So now you're talking not a pattern in terms of the MAPE loop. You're talking about a pattern about planning, a pattern about analyzing, whatever, all right? But it's not anymore, all right, the pattern about the MAPE. That paper, the original paper is a beautiful paper in the sense that they simplify to the basic stages of the MAPE loop, all right? But now it looks like you're adding something. And this was when watching your presentation, this was it caught my attention because it's so nice that that set of patterns that now you're breaking those patterns. But the patterns you should be introducing is at the level of the stages, not at the level of the abstraction. So essentially breaking abstraction, essentially. Right. So yeah, I think this is more or less in the same lines as the Gabriel. Right. So, but I was thinking in terms of the notion of an abstraction, because there is an abstraction.
I mean, it depends. It's kind of a way of how you look at it, right? So I think the original patterns, it's fine, and I like them. But then if you want to, for example, judge the solution based on multiple kind of criteria, or you want to know how it specifically works, then I think it could be useful to also add these things to the pattern and then have a direct look at what is actually being used, or trying to explicitly model this in the system. I think in that sense, it's an added value there.
Okay, I think the abstraction, your abstraction is at the stage level, not at the MAPE level. All right, that's my point.
Ah, okay.
Okay? You understand? So if you want to introduce a pattern for the planning. All right, there might be several patterns, and it goes in line what Gabriel was saying. All right, so there is a lot of patterns for planning. There is a lot of patterns for analyzing. All right, so what you're saying is that what kind of pattern exists for this type of stage. All right, that's what, because the pattern, the MAPE, right, is fine. All right, it's fine as it is. Okay, at least my view. Radu, do I've got the right to the second question, or just will allow me one?
Absolutely, you can carry on.
Okay, so this is the easy question, Friedrich. All right, so because I don't know anything about this. All right, so the issue is that it was quite nice that you have done your study, all right, across several communities. Right, so you look at Axus, Azu, Taz, whatever, all right, agent communities. So how many references to this paper in particular have you seen in other communities? So I'm trying to figure out the cross community culture now. All right, so you've got all these communities talking essentially about the same things, coming with very similar solutions, all right, but not talking to each other. All right, so since you've done this in-depth study, I wonder whether you have seen this paper, which I like very much. All right, this is one of the papers come out from the book, which I like very much. This paper, all right, and it's very useful actually. And on other communities referring to this paper, have you come up? A lot of people do that? No.
Yes, quite a few. I think in terms of citations, there were 300 papers that we went through. And in terms of venues, it was very different. Although, of course, not all of the papers that cited that paper were specifically applying some sort of self-adaptation there. But it's definitely referenced in a lot of communities, as far as we could tell.
No, but I'm looking particularly at self-adaptation one.
Particularly in self-adaptation. See, but then I don't know if I can answer your question completely, because I'm not aware of very specific different communities in terms of self-adaptation. So I know the most general community, but in terms of very different communities, I would like to ask maybe what you mean specifically by that.
Okay. Essentially, if you're going to Tazu, you're going to Tazu. With Axus, you're going to agents. There is always something there, doing a different way. You're using different technology, different terms, different culture, but it's there, all right? What you're trying to do is there. So using different tools, different techniques. So, and that's why I was trying to understand whether the same very simplistic view from the software engineering point of view, all right, is being applied, for example, or referenced at least in the agent community, right? So, and that is I
think that's less the case.
It's less the case.
Yeah, less the case. It's mostly contained to self-adaptation, or at least the self-adaptation that I'm particularly aware of.
All right. I know that in your presentation you mentioned there seams, how many references there seems there. All right. Thank you very much. That's all. Thank you, Rodney. Thank you, Federico.
Thank you.
Next question, Janina, you wanted to ask Messias more about his work.
All right. Okay. Yes, it was also a nice work. I enjoyed especially the presentation was really helpful. I was wondering one thing in particular is also a curiosity. When you mentioned the use of machine learning in the microservices, let's say this self-adaptive microservices. At least in my opinion, I was thinking more of architectural issues other than use of machine learning on those kind of solutions. So, and then you mentioned something very briefly on that sense. So I was curious if you could elaborate more on this. What exactly you mean by use of machine learning, self-adaptive microservice solutions that, as I mean, like the issues, I think the contributions that microservices can add more on this is more related to architectural issues, but not on the optimization issues. So what exactly you mean by this? Can you, maybe this could help us to have a look at some directions you have overlooked?
Okay, so we haven't explored that area yet, but at this point, we cite the use of machine learning, for example, provides proactive adaptations. For example, there may be situations in which the system could predict a large number of requests arriving at a given microservice. And in this way, the system would automatically scaling more microservices to be able to meet the demand and maintain a stable performance level. So so that would be interesting, a case to explore. It was a case in which we thought.
Hi, Janaína. Let me also complement the answer of Messias. We think that we can use machine learning techniques to not only to predict some coming events, but also to make the system more reliable and more resilient. And so, for instance, if the system has suffered some attack, we can learn how those attacks have been done, and then trying to create a more intelligent, self-protecting approach for the system. And also we can think about a more intelligent, decentralized approach that may be related to the question of Danny. So machine learning could also help us to understand better and to improve communication between the microservices. So the centralized approach could be implemented more in a more robust way.
Yeah, but I was wondering if this is a problem of microservices or the problem is self-adaptive system as a whole. You see what I mean? So I'm not sure if the problem is placed as in the microservices. I don't know, maybe microservices could help see something that we have overlooked in the other contributions of a self-adaptive system as a whole. But it's just my impression if this is a problem for microservices or if it's a problem of self-adaptive system as a whole and the contributions that have used already.
Yes, I would say that is a problem for the microservice community. So they can rely on self-adaptive techniques to improve their resilience and system architecture, this kind of thing. And what we saw is that there are work that use machine learning for making microservices architecture self-adaptive. So this is what a point that we mentioned as a possibility for research directions.
You wanted to add something to the discussion, Rogerio, or is that a separate question?
It's precisely on discussion because I had a question related to this. All right.
Right. We have a minute left.
Okay, Paulo, you mentioned two things there. The first part I disagree with most, but the second part I agree with most. But I think I couldn't kind of understand the two bits you talked there. All right. Okay. So one thing is clear. And I'm looking from the resilience point of view. My resilience might be different from your resilience, all right, but also from security point of view, all right. And from the security point of view, all right, I'm talking with people microservices. Microservices mess up everything, all right. Essentially mess up because you don't have. There is a lot of services that require the provision of security services in systems that are centralized. all right? And that the microservices with all this communication, point-to-point communication, there is no central view of the system, and we're dead, essentially. All right. So, and that's the issue. Now, how to incorporate decentralization, all right, at a level of self-adaptability? That's what Janaina was saying, all right? That is another kind of worms, all right, concerning security and resilience in particular, all right? So you in the second part of your answer to Janaina, you're spot on, but the first one, I couldn't understand what was going on there. I'm sorry, all right? So this was, and that was my comment I was going to ask, all right? So I didn't understand from the paper when you mentioned some things like insecurity, in particular, insecurity, regarding centralization, decentralization, not specified. How can you classify a paper on security? Microservices is not classified where centralized or not centralized. And there is another one, not applicable. How can a paper on security, there is no architecture centralized or centralized? I don't understand, not applicable, I'm sorry, all right? So, and this is a particular table on the paper that I was referring to, two tables. I was comparing, I was just madly cross information, and I didn't follow it. I didn't understand that. I'm sorry.
Right. Would you like to answer that quickly in 10, 15 seconds? Because we need to rest our eyes before the 2-hour debate, right? So if you want to say a few words, Paula.
Okay, maybe we can have this discussion through the Cloudar. Maybe we can also continue.
I think that would be wise to take it to the social
exactly.
event, for instance.
Exactly. But thank you, Jerry, for your comments. So we'll try to answer your questions, okay? And thank you, Janaina.
Right. Thanks very much, the authors and everyone, for being such a nice audience that I had no chance to ask my own questions. So please rest your eyes for a few minutes and come back to our 2021 community debate in 3 minutes now.